Okay, so first off, y-intercept should plug in 0 for x, and you get 0 minus 0 over 0 minus 0 minus 9, but 0 divided by negative 9 is 0. So your graph should go through the origin. For x-intercepts, vertical asymptotes, and holes, you have to know what numbers make the numerator 0 and what numbers make the denominator 0. So that implies that you factor it, and if it factors more than once, you probably want to factor it more than once. So even if it takes you a bit, you need to know that these three numbers make the numerator 0. Always the GCF first. And it looks like negative 1 and 3 makes the denominator 0. Now, I go through that pretty quickly, but I've factored a lot more questions than you guys have. You don't want to rush that step, because if you mess these up, then your graph looks way off. Then your graph looks confusing because stuff is like not making sense. And then you have to start over anyway. So don't rush the factoring. So any number that makes just the numerator 0 ends up being an x-intercept. So that was 0 and negative 3. 0 we should have known because the origin's not just a y-intercept, it's also an x-intercept, but it's good to see that the algebra is consistent with that. Any number that made just the denominator 0 is a vertical asymptote. And any number that makes both the numerator and denominator 0 at the same time is the x value of your whole. The y value of your whole comes from plugging in the x value into the reduced fraction. If you don't reduce it, you're going to get 0 over 0. And 0 over 0 can be anything. So you need to let x minus 3 cancel out x minus 3, and then you plug 3 into what's left over. And you get 18 over 12, which reduces to 9 over 6, which reduces to 3 over 2. So even though the graph does not hit that point, it's still going to help us with our graph, and we need to show it as a big open circle. Okay, domain asks what can I plug in, so I can plug in almost any x value I want to, so I'm going to show that with the number line. But I can't plug in any number that makes me divide by 0. So I get to reuse this information and say negative 1 can't be part of my domain and 3 can't be part of my domain. So anything less than negative 1, which we would write like this. Anything between negative 1 and 3, which we would write like this. And then finally anything bigger than 3, which we should write like that. Now, when I tell you guys to check your graphs with the calculator, of course this is not going to show up on your calculator. Your calculator doesn't tell you what the domain is, so that's why it checks most of it but not everything. Okay, horizontal asymptote, you have to compare the degrees. If the degree of the denominator is bigger, it's y equals 0. If the degrees are equal, you do leading coefficient over leading coefficient. But if the degree of the numerator is bigger, then you don't have one. And then slant asymptote only has one if the degree of the numerator is 1 bigger than the degree of the denominator, which is true in this one. So okay, so how you find the slant asymptote is with long division, except we will ignore any remainder. It's going to be y equals whatever the quotient is. So I know this should be 1/3 x, because 1/3 times 3 gives me 1, and x times x squared gives me x cubed. Then 1/3 times negative 6x would be negative, see, multiplying by a third is like dividing by 2. So negative 2x squared, and then times negative 9 would be negative 3x. Multiplying by a third is like dividing by 3. Change the signs and add. Now be careful here. x's and x squareds are not like terms. You can't force these together. These are x's and these are x's, so you can combine these together. And then it looks like we could go one more time, because there is a number times 3x squared that gives me 2x squared. So if I was to multiply by 1/3, that divides by 3. So 3 divided by 3 gives me 1, but I want it to be 2. So I want it to be 2 bigger than that, so we're going to make it 2/3. So 2/3 times this gives me this. 2/3 times this. See, positive times a negative. Can I erase that? It's in my way. Positive times a negative is negative. Dividing by 3 would make this a 2. Times it by 2 makes it a 4. And then positive times a negative is negative. 9 divided by 3 would be 3. Times 2 would be 6. And it looks like we get that as a remainder, which the nice thing about slant asymptotes is if I make a careless mistake at the end of the long division, which is very common, I can still get the slant asymptote correct because I just need the quotient. So if we start to throw all this information on our graph, we need to see how close we are to being finished there. Sometimes that's going to be plenty, and sometimes we need to plug in a few more points, which is why there's that little table there. Asymptotes are dashed lines, whether they're slant, vertical, or horizontal. Now the slant asymptote is in mx plus b format. So I know it's got a y-intercept of 2/3 and a slope of one-third. Okay, and then of course more points makes your graph more accurate, can make you feel good about the graph, but our graph should be finished here as long as you know it has to approach slant and horizontal lines at the ends of the graph. Then based on this direction, this one must be spiking down on the right side of the vertical asymptote and so up on the left side of the vertical asymptote. None of that is like in each other's way. There's nothing conflicting. So I feel pretty good about my graph. And this would be where I would jump over to my calculator, throw it in the graph, and do just a quick scan. Make sure that it looks the same before I moved on. And of course, if it doesn't look the same, it should be giving you some clues about what you may have done differently. If you thought there was 2 x-intercepts, but the calculator only graphs 1, then that tells you to rework that part of the question. Okay, so there's their graph. And my graph looks very similar. So I'm happy with that. Now again, your graph does a very poor job of showing holes. So checking your graph with the calculator graph isn't 100% going to guarantee that everything's right, but it should help you see, quickly see if there's something majorly wrong. Okay, so which or any of these parts you guys want me to explain what I did again? Yeah.
Can you explain how you got 2/3 for the y value of the whole? I mean 3/2.
Sure. So you're okay with the 3 value?
Yeah.
Okay, so the y value of the whole comes from plugging in the x value of the whole into the reduced function. If you plug this into the function,
Yeah.
you get 0/0. And 0/0 can be anything. It just depends on which one's going to 0 quicker. In fact, that's one of the first things that we do in calculus is learn how to deal with that. So you've got to look at this, look at your factored version so that you can reduce it. Let x minus 3 cancel out x minus 3. and then I plugged 3 into the rest of that, and then I did the arithmetic there. Is that okay?
Yeah.
Okay.
Thank you.
Any other parts y'all need to speak up and ask about? And again, that the y value of the whole is often something that students, like one of the last things students feel comfortable with, which is fine. Part of the problem is not every question has a whole, so you don't get to practice it 10 times in a row. You get to practice it on one question and then maybe not again for a few more questions. But that's where on your box on the top page, make sure you have some kind of descriptor there so that you can look it up as many times as you need to until you know it.